All right, welcome back. So the first thing I want to point out about the convolution is that you don't have this quality. You don't have that one starred f equals f necessarily. That's not true. Okay, let's take a look at an example actually. We're going to take 1 starred with sine of t. Okay, so formally that's going to be the integral from 0 to t. Okay, 1 times sine of t minus v dv. Okay, now there's actually another way to go about it. We could also write this. I'm not going to, well, I'll go through it a little bit. Write this as from 0 to t, u of t minus v, right? This is the step function. Okay, times the sine of t minus v dv. And we can do a little change of variables on here. Okay, so we'll go ahead and do a change of variables. Actually, keep that in blue. I guess we're doing it this way. Okay, so let's let w equal t minus v. Okay, so dw equals negative dv. So we get, now, when v equals t, right, w is going to equal, I'm sorry, when v equals 0, w is going to equal t. We get a negative from the dw, t. When v equals t, w is going to equal 0. Okay. Now we're going to have u of w sine of w dw. Okay, now we're going to go ahead, let's flip that integral around. Write this from 0 to t. I can drop the u now. Okay, so I added it in order to get that integration going. Okay, I had to add it in. Did I need to add it in? I guess I really didn't need to add it in. Okay, but now I'm going to switch the integral, and I'm going to have the integral from 0 to t sine of w dw. Okay. Yeah, I really didn't need to add that u in. And now that's going to be cosine of t, negative cosine of t plus 1. Let me just do that in steps. Negative cosine of w from 0 to t. Okay, so that's going to be negative cosine t plus 1, which is 1 minus cosine t. Okay. I had another way to do this. Okay, another way that I could do this. Let's do it in red. Take the integral from 0 to t. And the way that I did this the first time is I did it using a sign identity. Sine of t cosine u v minus sine v cosine t dv. Okay. Pulling out the sine of t, 0 to t cosine v dv minus cosine t, integral from 0 to t sine v dv. Sine t The integral of cosine, remember, is negative sine just sine. Minus cosine t. Integral of sine is negative cosine. So we get sine squared of t. Sine of 0 is 0, so I don't have to worry about that. Minus plus cosine squared of t minus cosine of t. Okay, so what's happening here? At t, you get the cosine t, so that's the cosine squared. At 0, you get the 1 here, right? So negative cosine t times negative 1 is the negative cosine t. But this is simply 1 minus cosine t, which is the same thing we had up here, over here. Okay, so two different ways to get the same thing, but neither one of them are what we started with. Okay, so one starred with a function is not going to give us back the function necessarily. Okay, all right. Let me go through that proof real quick. This is actually, this proof or this concept about the convolution being the Laplace transform of the convolution being the product of the convolutions. That's also important in Fourier transforms as well, which you'll learn in another class. But it's also what makes convolutions work there too. Okay, so what we're going to show here real quick is that L of f star g equals L of f times L of g. Okay, so we're going to start from here. This equals the integral from 0 to infinity e to the negative st times the integral from 0 to t f of t minus v g of v dv. And that's dt. Okay, so this integral in t is the Laplace transform, and this integral in v is the convolution. Okay, so now we're going to use that trick. We're going to multiply by a step function. So putting that step function in, the one we didn't need up there, okay, the one we didn't need up there, but we're going to do it here. Okay, so we're going to make that an integral from 0 to infinity. That's what it's going to do for us. U to the t minus v, f of t minus v, g of v, dv, dt. So remember, what this thing does is this cuts. This is 0, or I'm sorry, this is 1 from v going from 0 to t. And then it becomes 0 after t. So this integral is the same as this integral when we put that in. Okay? But now we're going to go ahead, we're going to pull out that g of v and change the order of integration. Okay, so mathematicians like to say you mumble something in Italian and then you can change the order of integration. Probably doesn't make any sense to you now, but I assure you that's a really funny joke. Okay, all right, so mumbling our little Italian, okay, and we get the integral from 0 to infinity. We're going to pull that g of v out, okay. We're going to have the integral from 0 to infinity, e to the negative st u t minus v f t minus v. This is dt. This is dv. Okay, so now, just a second. This is the Fourier transform, or I'm sorry, the Laplace transform of u of t minus v, f of t minus v, right? So we're going to use Laplace transform table number 10. Okay, so we're going to get the integral from 0 to infinity, g of v. This is going to give us an e to the negative sv times the Laplace transform of f. Okay? But now this f of s can pull out, and this is simply the Laplace transform of g. Okay? So that is the sort of convolution theorem for Laplace transforms. Okay? All right, I'll see you all in the next video.